Welcome to qnawire.
Hi, so for this problem, the first thing that we need to do is identify the oxidation reaction and the reduction reaction. So what we're going to have in this cell is the oxidation of H2 gas in order to produce 2H plus and 2 electrons, and we're given the concentration of H plus, and we know that the value for E0 for that pair is equal to 0 volts, and we're going to have the reduction half reaction corresponding to gold 3 plus 3 electrons generating gold solid. And we want to know what is the concentration for gold 3 plus. For this half reaction, we have E0 is equal to 1.5 volts. So the next step is finding the overall reaction. And for that, we need to find the common factor in between those two, that is 3 and 2. So multiplying the oxidation reaction by 3 and the reduction reaction by 2 and adding things up, we end up with this overall reaction, in which we have exchanged a number of 6 total electrons. Next up, we can calculate the E0 for the cell by taking the E0 for the cathode minus E0 for the anode. Remember, in the cathode, we have the reduction, we have consonant with consonant, just for you to remember, and E0 of the anode is the oxidation, vowel with vowel. Okay? So the E0 for our cell is going to be 1.5 volts, but the target that we want to get is 1.27 volts, and the other information that we have is that we have exchanged a total of 6 electrons. For this, the result that we're going to employ is going to be using Nernst equation in order to solve our problem here. So Nernst equation tells us that the potential of the cell it is going to depend on the E0 of the total cell minus 0.059 divided by n logarithm of Q. What is Q in our case? Q, it is going to be, if we look at the overall reaction, this one over here, Q, it is going to be concentration of H plus to the 6 divided by concentration of gold 3 plus squared. Nice. So the next step that we need to do is replace the values. We know that the target is going to be 1.27. This is going to be equal to 1.50. That is the standard potential minus 0.059 divided by n, that is 6, the logarithm of Q. The concentration of H plus elevated to the 6, it is going to be equal to 1 divided by the concentration of gold 3 plus squared. And this is the quantity that we need to solve for. Here, just taking a step-by-step procedure, we are going to get 1.27 minus 1.5. It is going to be minus 0.059 divided by 6 times the logarithm of 1 over concentration of gold 3 plus. But recall that by this quantity squared. But recall that by laws of logarithms, logarithm of 1 over x is the same as taking the logarithm of x to the minus 1, which is minus logarithm of x. So we're going to take advantage of that property. On the left-hand side, we are going to end up with minus 0.23. This is going to be equal, taking this minus into account, divided by 6. I'm going to be explicit about it. This section now becomes minus logarithm of gold 3 plus squared. And of course, these two quantities are multiplying each other. So minus and minus are going to cancel out. So minus 0.23, it is going to be 0.059 divided by 6 logarithm of the concentration of gold squared. Cool. So now solving for that concentration, we are going to get 10 to the minus 0.23 times 6 divided by 0.059, and all of this we are going to take the square root. Just for doing this step by step, this is 10 to the minus 23.389 to the 1/2, which turned out to be 2.02 times 10 to the minus 12 molar. And this is going to be our final concentration of gold 3+.